Welcome back to Structural Analysis Made Fun and Easy. Here's the first worked example. Shearing resistance of a soil sample using a shear box test. Worked examples. Describe briefly laboratory shear box equipment and the shear box test. Samples of compacted clean dry sand were tested in a shear box which was 254 millimeters times 254 millimeters in plan. Don't know where they get those dimensions. Why can't they just make it 250? During slow drained shear, the following results were obtained. Sample 1, 2, 3. Normal load 500, 1000, 1500 kg. Peak shear force 4.2. Ultimate shear force as shown in the table. Determine the angle of shearing resistance for the sand in 1, the dense state and the loose state. What type of sand has been tested? What type of sand has been tested? Is it like well compacted or... okay. So the solution is this. The shear box test is normally used to determine the shear resistance of a cohesionless soil. That means sand and not clay. Sand and silts then. The apparatus is shown diagrammatically in figure 4.4. The box is 60 millimeters squared. That's weird. The box is 60 millimeters squared. Open at the top and bottom and divided horizontally into two halves. It is placed in a rectangular container designed to hold the bottom half of the box rigidly in position. Oh, is that that? Oh, hold on. No. It says, it is placed in a rectangular container designed to hold the bottom half of the box rigidly in position. But that looks like it's the top that's being held in position. That looks like it's the top, not the bottom. The top is her... oh. And what we're going to have to do is we need to go to YouTube, look at a video of a shear box test. A porous stone is placed in the bottom of the box, followed by a perforated toothed metal plate. That's to grip the soil. The soil sample is then placed in the box with another plate and porous stone on top. To me, that looks like the bottom half of it moves because it's got the shearing force. That bottom part of that box is on rollers, and then that's moving, and then you know the top bit, the proving ring is that's showing the deflection of the top half, which is connected to the bottom half via the soil. So the soil is being tested in shear. The sand. Why don't they just put sand instead of soil? Put sand silt. So stupid. Above the top porous stone, a pressure pad is placed. Above the top porous... oh yeah, right. So the pressure pad, that's where the normal load goes. The test is performed by applying a vertical load to the sample and then applying a horizontal force at a constant rate of strain. That's the bottom part of it, isn't it? Shearing force at the bottom. A constant rate of strain until the sample fails in shear, i.e. the particles are going to move relative to one another. The horizontal shearing force is measured by means of a proving ring. Alright. So that's what's transferred, yeah. So it slides at the bottom and then it records at the top. The horizontal, yeah, right. This procedure is repeated on similar samples of soil with different vertical loads. From the results obtained, a graph is plotted of shearing force versus normal vertical load or shearing stresses at failure versus vertical stress. From the results obtained, a graph is plotted of shearing force versus normal vertical load or shearing stress at failure versus vertical stress. A straight line drawn through the points obtained is taken to represent the Coulomb equation and the value of phi found from the graph. It should be noted that If measurements are taken off the graph, the same scale must be used on both axes. The forces have been converted to stresses by dividing the area of the shear box. Oh, right, yeah. All right, so that's this table. And then dividing by the area of the sample. They are plotted on figure 4.5, from which the following values have been read off. Dense state 5-44, loose state 32. Okay. Dense state, loose state, is that? Should be. Huh. I thought there should be 3, because you got 3 samples. Shouldn't there be 3 lines? Normal stress. Okay. Come back to that. Okay. The soil tested was probably a well-graded sand with angular particles. A uniform sand with rounded particles would have had lower values of phi dash. Oh, okay then. So that's that example there. Okay, that's that example done. So hopefully you found this enjoyable, and please like the video and subscribe to the channel. Then you can we can go over that results again. Thanks for watching. See you in the next video.